While chatbots and AI-generated videos both feel like black magic, it doesn't mean that they are both born equally. They are indeed machine learning concepts, but just look at this. This is the math for attention and language modeling, and this is the math for only the denoising process in diffusion for image generation. On top of that, the majority of progress in language modeling has come not from architectural changes, but from scaling up data in model size. While image generation is currently on its fourth architectural evolution that went from GANs, VQGAN plus clip, latent diffusion, and now diffusion transformers, language modeling has been sitting on transformers this whole time, with each and every one of the image generators being a mathematical hell that makes you wonder, how in the world did people come up with this? As for video generation, the same machine learning idea from image generation could be applied too. And of course, it would be more complicated since it needs to accommodate the time dimension in order to have it become a video generator. So in this video, I'll be providing a conceptual overview of how video generators are made. This won't be a detailed mathematical breakdown, so if you're looking for something more technical, I'll link them down in the description. But it seems no one has created an explanation video on diffusion transformer-based video generator yet, which is unfortunate. And since there is barely any fully open-sourced research about high-quality video generation like Sora, people like us have no way to really learn how it is made and built from the ground up. If you ask anyone that knows Sora, how does DEET for video generation work, they would most likely not know anything about it. But luckily, the open source god has blessed us with this project called Open Sora, developed by a bunch of brilliant open source researchers. It contains the golden knowledge we need in learning how Sora, or even a decent video generator, is actually made. But before we dive into it, let's take a big step back and understand the core objectives we are dealing with. So video generation can be summarized into two key challenges. The first is the generation quality, basically how visually appealing and realistic each frame of the video looks. Since image generation has made significant advances, video generation often builds on these techniques to create high-quality individual frames. So this is not as big of a challenge as image generation has been pretty much perfected. The second challenge is temporal consistency. This involves making sure there are smooth transitions and coherent motion across frames. And so far, achieving seamless temporal consistency remains the most difficult aspect of video generation to this day. While it may sound simple, it requires simulating complex dynamics and sticking to the laws of physics to make movements appear natural and believable between frames. That's why people call video generators a world simulator, as it essentially needs to do what a physics simulator is able to do for every possible and logical motion we can imagine. Which brings us to the latest configuration of Open Sora. Since image generation models are already really good, rather than reinventing the wheel, Open Sora adapted an existing and powerful text-to-image model called Pixar Alpha. Even if you're not familiar with the name, you may have come across it. Not for its image generation, but for that one controversial carbon emission diagram published in its research paper. Despite the controversy, Pixar Alpha is still known for being an efficiently trained, high-quality image generation model, making it an ideal choice for cost savings, especially considering how cheaply the open-source researchers are. This text-to-image model is also a diffusion transformer model, which means unlike standard diffusion-based models, it doesn't use units to process images, that is, to obtain fine details and big features through compressing and expanding an image. Instead, this model uses a transformer to replace the part to process images. Why the switch? So the image generation researchers probably looked over at the language model researchers and saw their state-of-the-art architecture has not changed at all in the past few years, which gave rise to using an NLP architecture for image generation tasks. And it works. All you have to do is to make the transformer denoise. Some suspect that while units are great at processing local patterns, transformers are better at capturing global patterns in data, thanks to their attention mechanism. This means that deep models can potentially offer a better understanding of complex relationships across large image dimensions, even with the addition of the time dimension, which would make more sense when we need to consider temporal consistency in video generation. So a slight modification is needed from the PixArt alpha structure.